I want to welcome Sue, who's also with us, and she has the first session of the day. Hi, Sue. You can also turn on the camera.
Yep. It says I can't because my host has stopped it. So let me.
All right. If there's something we can fix, we will.
Hold on. Let's see. Start video.
Yes, perfect.
And I take it you can hear me.
Yes, loud and clear.
Brilliant.
Yeah, so you're going to have the first session of the day. I was looking at the title. It's called A Plea for Test Techniques. And I feel the need to ask you, from the sound of the title, it sounds like some things are not going as we want to, sometimes at least. So that's why the plea. So some things need to be done differently, or yeah, how would you position it?
Yes, I do think that, well, as I'll say in the talk, I think that people aren't using techniques to their fullest advantage. So, you know, hopefully within the talk, it should highlight what it is in terms of my plea for testing techniques. All
right, so I'm not going to steal your thunder, so I'm going to let you do it. But I do resonate a bit with this, and we had this conversation throughout the past few days, also on other topics. Like, yeah, the software industry, although compared to other industry, it's pretty young, but we went through a lot of things. We created a pretty big body of knowledge around various aspects, but still things are not that streamlined. I mean, yeah, it works great if we're talking about, I think Alistair Colburn said it once, yeah, software works great with 4 developers and a whiteboard. But then we need yeah, all these practices that we're thinking of and trying to introduce. They're meant to help us scale, and we're not there yet where everything is streamlined. But yeah, enough. Let's I'll give you the floor, and then we regroup at the end for more discussion.
Brilliant. Okay. Well, firstly, thank you very much for inviting me to the conference, and really look forward to the rest of the day in terms of the testing stuff. So brilliant. Okay, in this particular session, I'd like to talk to you about what, 4 things really, 4 elements. Firstly, what constitutes a technique? I then want to have a look at what's great about techniques, where I think it's gone wrong for techniques, and then I'd like to introduce you to some of my favorites. So if we have a look at the first part in terms of what constitutes a technique, well, one definition that we have is that of a test design technique is a standardized method of deriving test cases from a particular test basis that will achieve a certain level of coverage. Now, that's a fairly dry definition of a testing technique. My definition is somewhat more loose than that. In terms of that, I use the definition in terms of a stepwise methodical process that helps you identify potential test cases and trap bugs. And you need to be a little bit careful about the language here, or at least observe the language, because as you can see from my definition, we've got the idea of a methodical process. So as well as talking about techniques, we're also talking about methods. We're also talking about approaches. So a method says a procedure or process for attaining an object, such as a systematic procedure, a technique, or a mode of inquiry. So, and at the end of that one, it says to a particular discipline or art. Now, obviously, I'm a tester, and I would suggest that testing is an art, as well as a stepwise process. So that's the definition in terms of the method. We can also look at the definition of a technique. So a technique, another way of looking at a particular method, again, of doing an activity, usually a method that involves practical skills. So once again, skills, stepwise process, etc. But with this looser definition of techniques, we can bring all sorts of things into the realm of testing techniques. My favorite is that of mind mapping. To me, mind mapping is an absolutely glorious testing technique because I can use it for all sorts of elements. Here I've got a very short little mind map looking at root cause analysis of the Titanic disaster. Again, just showing that you can do something like that with mind maps. But we can take techniques even further. There's a really useful deck of cards that you can get from an organization called the Ministry of Testing, where they have as I say, it's a deck of cards. They call them the test sphere cards. And those cards allow you to pull out approaches, methods, and make you think. Comes back to what I was saying in terms of my definition. So what's great about techniques? Well, I suppose what I should really say is, what do I think is great about techniques? The first thing about what I think is great is that there are so many of them. We've got techniques that cover everything and anything that you can think of. Just breaking it down on that particular chart, we've got techniques that help you with static testing, so static analysis, data flow analysis, informal reviews, technical reviews, inspections, all on those technique sides for looking at documents, code, etc. Then when we move on to the dynamic side, we've got some white box based testing techniques, so things like statement testing, decision testing, decision combination, modified branch testing, etc. We can then move across into the black box testing techniques approach. We've got functional testing techniques, non-functional, experience-based. There's just so many of them, so many techniques, so little time. But generally, if you're looking at something, there is a technique out there that can help you. Tie that in with the idea of some other great things around testing. One of the things that I find to be most useful is that they help alter your perspective on things. I'm a very, I don't know, I have a particular way of looking at testing, and I can sometimes go too deep, too quickly, focusing on the fault finding capability. And I'm basically a bug hunting tester. But testing is more than that. It's not just that. So I use the techniques to pull my focus back to help me look for specific things. So if I'm working on a particular project and I need to focus on how the code might be structured, then I'll use a technique that helps me focus on that. So something like boundary value analysis or data flow testing will help me concentrate rather than just constantly going on the bug hunt. Another aspect, they generally have a visual element. I'm very much a visual thinker. I like to draw diagrams. Everything's color and color coded this and color coded that. So I need something where I can actually draw out the picture of what's going on. And most of the techniques have a visual element. So it makes it easy for me to understand what I'm doing and also for my colleagues to understand what I'm doing. Another aspect of the techniques, they can be extended. So the classic extension is that of coverage measures. So we can use the technique to look for the problems within the system, but then we can extend it by looking for coverage measures to see how far have we done, how much of the application have we actually covered. And in most instances, the technique started off at low-level testing. So quite a lot of them came in with the focus of component level, or even hardware elements. But we can alter those, we can use them, we can take the practices, the steps that we're doing, and move them up into business level approaches. So we can use the techniques and the steps to give us a better picture of what's happening with the system. So that flexibility is immensely useful. So where do I think it's gone wrong for techniques? And again, this is a purely personal view. Again, from my perspective, I think what's happened with techniques is that the explanations, the resources, where you would find out about techniques tend to be dry and difficult to understand. As a case in point, and I'm not going to knock the thing itself, but as a case in point, this is one of my favorite resources. And you can probably see, well, hopefully you can see, it's well used, it's torn to pieces. I should really print off another copy. This is the Standard for Component Software Testing, otherwise known as BS 7925, Part 2. Specifically Part 2, because Part 1 is the glossary of testing terms. And I'm not going to knock it too much because I know quite a few of the people who've actually produced this document, so and I don't want to knock their work. And also we need to judge the document by its time, because it was produced in 1997. Things have obviously moved on in terms of presentation. But it's an absolutely brilliant resource if you wanted to find out about classic techniques such as equivalence partitioning, boundary value analysis, etc. And at the end of the presentation, I have got a link as to where you can find this document so as you can have a look yourself. So it's a really useful document for the basic techniques. Having said that, you've got to want to understand that document. You've got to have a puzzle solving mind. You've got to take the time to decode the technique and understand how it works before you can start to apply it. So it makes it more difficult for people to access those sorts of things. Again, other resources, there are plenty of books on testing techniques. You may see some of them in the background on the shelf. For example, I've got Software Testing Techniques, classic one from Boris Beiser. You really have to want to work at it in order to get the information out of there. The trouble with that, and I think that's the root cause, because the trouble with that is then this makes people think that techniques are hard or complex to do, difficult to apply in the real world, time-consuming, unwieldy, or even worse, won't work on my project. Especially if you're working on an agile project. So what can we do about that? Well, personally, and again, as I say, I think it's a personal view, I think the techniques provide really useful information that might be missed if you're not using them. So if we can find a way of explaining the techniques, getting people to work with them, seeing how they develop, then you've got more of a chance of finding those sorts of problems. And you may develop a favorite technique, a go-to technique. I know, certainly going back to the standard for a second, there's one technique in there called cause and effect graphing, which I hate. Even though it's a visual technique, I have never mastered it. And there are things like that, you just won't get them, you just won't master them. So not every technique is going to gel with you, but if we can find a good way of explaining them, you should be able to see where the value is. Most of the techniques are based on patterns, and once you've learnt the pattern, it's easy to learn the technique. Once you understand the pattern and the technique, and you get to like it, you grow to understand it, then they're quick and easy to set up, and they become second nature, which then takes you onto the Agile project, because in effect, when you're moving to an agile project, even if you haven't got all the time to set up the charts and the tables and anything else that you might use, you've still got your technique goggles, if you like. So if I can switch into technique mode and look for equivalence partitions and boundary values, I've got them there in my head. I don't actually need to do anything in terms of using pieces of paper or anything. I can draw it out that way. Of course, the other big plus is that many of them actually have tool support. Not quite the case back in '97, but certainly now there are a lot of really good tools out there, and people have recognized that it's worth spending the money on developing these tools so as people can get this benefit, the extra elements found using the techniques. So let's have a look at some of the good ones, some of my favorite techniques, and see how they fit. And maybe in the question and answer session at the end, you can, if you've got a favorite, you could let me know. So the first one we'll have a look at is pairwise analysis and testing. I adore pairwise testing. It makes me feel like a magician, a combination of a magician and a mathematician. This one makes me look so good. I can go to people and say, look, see all that testing you thought you had to do? I can reduce that down and still maintain the quality. Now, that sounds like a really good sell, doesn't it, as to what we can do with the technique? So, why would we use it? Firstly, we've got this growing problem that in today's environment, we've got this massive amount of complexity. The applications that we're using require more inputs, have more paths through the system, access greater volumes of data. It's all gone a bit mad, as far as I'm concerned. So how can we test, how can we have confidence that our applications are handling everything correctly? And one such way of getting that confidence is using pairwise analysis and testing. So as an example, if we take a simple mobile phone system, we have three call types. We've got a free call, a local call, or an international call. We've got three call methods: a dialing of a call, using your phone book, or voice activation. And you've got two ways of paying for that call. You can either be pay-as-you-go or have a contract. If we look at that, how many combinations or routes do you think there might be through that simple system? Well, if we take the mathematics, we end up with 3 times 3 times 2, which gives us 18 possible combinations, which we can put out in a nice little mind map. And that tells me that if I wanted to do that thoroughly, looking at every single condition, I'm going to need 18 possible tests. But that's just a simple, one could say, Mickey Mouse application. How about a more realistic one? If we go to something like a car insurance system, with this one, we've got 3 policy types of third party, fire and theft, fully comprehensive. We've got 3 storage modes of garaged, on the drive, on the road, 4 no claims discounts, 2 license types, 5 age categories, 5 engine sizes. Okay, so now how many combinations have we got for this one? Well, if we multiply all of those together, it's 3 times 3 times 4 times 2 times 5 times 5. Oh yes, 1,800 combinations. So if I wanted to test that application fully and have total confidence in it, I'm going to need at least 1,800 tests. So that gives us this quality headache, that the large numbers of the combinations can't be ignored. I always have this fear that the one part of the application that I didn't test is where the biggest bug is. So I can't ignore it, I just need to think of a way of doing it. There's a risk of failure if some of those combinations are not executed together. testing all the combinations, especially at 1800, is impractical. So we need to find a way of actually dealing with this. And some of the combinations might not be feasible or sensible. So, for example, car insurance for a 17-year-old driver with 3 years no claims discount. He would be, 14 years old when started driving. It's just not going to work. So we need to identify a good subset of the combinations that will give us the greatest confidence against effort. And that's where pairwise analysis comes into play. So what's the idea behind it? Do excuse me, I'm British, so I need to have a sip of tea. No stereotypes, of course. Well, the idea behind pairwise is that many defects are either what we call single modal, that your component, for example, is either going to work or it's not going to work. And the other approach, double modal, that paired. So when a component is tested in its own right, it might work, but when you plug it in with another component, it might not work. So we're looking for that. It worked in its own right. Now we plug it together, it stopped working. There are other modes, so we can go into triples and all sorts of other bits and pieces. But again, that's the putting more effort in to find something that's reducing. So in this instance, we'll trap most of the problems with just looking at single modes or double modes. So if we take that and go back to our mobile phone, we need to go on a pair hunt. So we had our mobile phone that had the 3 call types, the 3 call methods, and the 2 account types. So now we need to look at all the possible pairs. So the first pair we could find is free and dial. That's our first pair. Then we've got free and book. Then we've got free and voice. And you can start to see the pattern. We just go hunting through the pairs. So if we pick out all the others, local and dial, etc. Going through that particular small mobile phone application, there are actually 21 pair types. So we can identify 21 pairs. Now we need to build the tests that cover those 21 pairs. So same thing, we've got our pairs, we can build the tests. So test number 1 is going to have the pair in it that's free and dial. Test number 2, free and book, and so on. Build those out. Well, that's great. We've got the pairs mapped out for free and dial and local and dial and international and dial, etc. But there's another set of pairs that we need to add in, but we can add them into the same test case. So if we add in, we've got the dial, so we need to add in dial, pay as you go, and book, contract. The other pairs we need are going to be dial, contract, and book, pay as you go. And we need to do the same for voice as well. Okay, so that's mapped out all of our payment types, and we've got some gaps. At this point, we've covered the pairs, so we don't really need to do anything more, but obviously that doesn't complete our test cases. So we could just leave them as blank or put a special character in there, which is basically saying to the tester, when they come to run that particular test case, they can put in there whatever they like. They can randomize that and pick a pay-as-you-go or a contract. And as long as they recorded what they picked when they ran the test, we're okay. So we could pick something to put in there ourselves, or we could just leave it with a notation to say, tester, you pick what you want. Okay, that's useful. Time consuming, yes, if we're doing it manually. This is where the magician part comes in, because if we were to look at the mobile phone element using the Pairwise, we had 18 test cases that we needed to run originally, But using the pairwise technique, we've now reduced that down to 9. Yeah, okay. Not much of a great saving at that point, but if we look at the more realistic application, say the car insurance one, we started off with 1,800 test cases, but now with Pairwise, dun, 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 I could reduce it down to 28. Yeah. Now, obviously, this is a bit one-sided at the moment. I'm really enthusiastic about it, and I'm hoping that you folks are basically saying, yeah, that's pretty impressive. So instead of 1,800 test cases, I can run in 28 test cases with the same confidence and factor that I have tested that application, because I believe in pairwise testing. The other really good news about this, I said earlier on, is most of the good testing techniques have tool support. So yes, doing pairwise manually can be time consuming and error prone. So great, let's use a tool. There's a really good little utility that you can get, it's free, called All Pairs, and you can pick that up from satisfice.com, which is James Back's website. But also, if you go to pairwise.org, there's all sorts of information about how to use pairwise testing, other tools that are available, etc. So, and there's an online one, which is great fun. You could even have a play with it after this particular presentation. Well, after the conference, because there's more presentations to come. So just to prove that it's not smoke and mirrors, this is a couple of snapshots of what I did with the All Pairs tool. So here we've got the input file that I created just using an Excel spreadsheet, and you can see there we've got the policy, we've got the storage type, no claims discount, the license, the age, and the engine. So I just put it into a spreadsheet file and upload it into the application. And the output file that it produced is sitting there. And again, not fantastic on whatever screen you're watching, but I'm more than happy to send that if people are interested. But as you can see, test case number 1, the policy was third party, the car was garaged, 0 no claims discount, full license, aged between 17 and 21, with an engine size of less than 1,000 cc. Just that one test case covered 15 of the pairs that we'd established. So it tells me that those combinations aren't, assuming that that test case ran okay, that those combinations are okay. Obviously, words of warning. We're not testing all the combinations. We're using an intelligent selection process to give us, if you like, the best bang for our buck. So instead of the 1,800 test cases, I've reduced it down to 28, but I still have confidence in what it's looking at. The method might not produce the most common combinations. Fortunately, test case number 1 for that example was actually pretty common. It was what we were looking for. There's also no priority given to the tests. It's down to the tester's skill to pick out which tests to run, and if there's anything missing, you can alter the combinations, although you have to be a bit careful in terms of if you alter things, is it disrupting the actual pairwise analysis? So my recommendation would be take what the tool gives you, and you've already saved so much from 1,800 down to 28 that adding in a few extra tests is not going to hurt. So where to use, when to use? Well, pairwise is really good, as it says, whenever you have large combinations that you need to refine. We want to test as many combinations as possible. What can we do that makes it more concise, refined down? It's really good to use if we've got a critical area, if you've got some calculations, pension calculations, mortgage calculations, anything where there's so many combinations that we need to consider that we want to focus in on those risks. But obviously it's not so good if we're looking at application flows we need other techniques to have a look at that. Okay, another one, classification trees. Now, I like this one because, as I say, from my element, it's the visual aspect. Now, the classification tree method, yeah, it's a partition method. And the idea is to use those partitions to visually represent what we're actually doing. So if we have a quick look at the classification trees, I won't go into massive detail around the classification tree activities, but more to have a look at how you actually build this tree. So the first thing is to look at the areas we're interested in, to look at the partitions and pull them actually into the technique and the diagram. This is one of those techniques that really is best using the diagram to illustrate. So as another example, if we take, for example, the pricing of a conference, not this conference because it's free, but other big conferences may have pricing. So we can recognize whether you have a power pass for the conference, whether it's an early bird for the conference, whether you're an alumni, having been to all the conferences, how many tutorial days you're working with, how many days the conference actually has, and whether you're going for a certification. Once we've got all the partitions, we can then push them into the tool. And as I say, this is a wonderfully visual tool because it runs a similar sort of calculation to Pairwise, but it gives me what looks a bit like a music chart. But you can read the test cases from left to right. So test case number 1 is saying power pass, yes. Early bird was after the date, so you don't get the discount. You are an alumni though, so there's going to be some benefits there. You haven't got any tutorials chosen, but you are going to the actual conference. And in this instance, you're not going for a certification. The main thing is you can see the visual element of what tests we're actually going to run and what parts are actually covered. So as we can see, every partition has been covered. So classification trees, the biggest benefit with this, it's a combination of a pairwise activity, a decision table activity, all pulled into one particular approach. But the biggest thing is the visibility. It's a beautiful illustrative method of seeing what tests we're going to run. And from that, it gives us the user buy-in. It's used in quite a few industries, so there's a lot of understanding of it, a lot of background behind it. And once again, wonderful tool support. Have a look at a tool called Test Owner. There are other tools, but the one I've used is one called Test Owner, and that's from a company in Germany. So when to use classification trees? Well, good for clarity of tests, logical combinations, and of course the visibility. Not so good for large systems, although if you break each tree down into smaller trees, then it can work. Conscious of the fact that I've been talking for quite a few minutes, I'd love to get to this last one, state transition testing, but very quickly. This was an illustration of a real project. State transition testing uses a model that talks about the states the software or system may occupy, the transitions between the states, the actions, sorry, the events and the actions. So once we've built our model, we can then pull out from that. That's going to, for some reason, it all decided to hang. Okay, so once we've built the model, we can then pull into the see, technology. So having built the model, we want to look at testing those elements. So either we want to test that we visited all the states, or gone down all of the transitions, or a combination of those. And we can do a sequence of transitions. So we can do transition pairs, which is another way of increasing things. The reason I wanted to show you this one is because this is one that where it shows you that a technique can actually really help save a project. On this particular project, the business thought that there were only going to be, I think, 4 states that a system, 3 states actually, that a system could use. And consequently, they were aiming to design it and test it with just those 3 states. But I was like, there's got to be a few more states. So I started to have a look at the states that I thought was there, and I put them into a nice mind map. So here we have a very large mind map. And as you can see from this very large mind map, slightly more than 3 states. We actually ended up with 15 states, although I think on the map I ended up with 16. And a lot more questions that the business analysts hadn't got answers to. So the state transition testing technique really helped in terms of improving what was going on with this particular project. So we just add in the transitions and then start running the actual tests by designing the test cases to hit every state or go down every transition or look at a combination of those. So when to use state transitions? Well, my answer would basically be anytime, every time. It's my go-to technique. If I get stuck for something, then I go straight to the state transition elements, and then start to look at what other techniques might be around. But ideally, it's good for application or process flows. Not so good, of course, for anything that requires combinatorial problems. I mentioned earlier on where you can find a copy of BS 7925 Part 2 without having to pay a fortune, which is another problem with the standards and documents as such. And you might want to have a look at testingstandards.co.uk, and you can actually find the standard on there in its draft form. So you don't have to pay for it. It's extremely useful. And you know, I don't mind promoting it outside of the British Standard Institute. So in terms of the slides and the chat and everything else, basically, yep, thank you for watching, and hopefully we can go back in terms of any questions.
Hi again, Sue. Yeah, thanks a lot. Very, very insightful. Especially I'm not into the testing discipline myself, but then yeah, it's good to have this overview. So I found it very interesting as well. I did have a couple of questions. For instance, clearly these are some of your favorite, let's say, techniques, and there are others, and everybody at some point has their affinity to one. But when do you decide during a project which techniques are you going to use, or which is applicable and how?
Again, a really good question. It's a difficult question because the techniques that you might outline at the start of a project might not be the ones that you are using by the end of the project. It's more, it depends on what problems you encounter. So if you encounter issues with decision logic, for example, if you're getting a lot of bugs where the values aren't coming out quite the way you anticipated, then that would push you into looking at maybe data flow testing or boundary value analysis. So it's almost the bugs that you're finding become the driver for what testing technique that you might want to use. It's all, yes, when you go into a project, I suppose like most folks, you would start a project with using a certain set of techniques in mind. And then as you work through, you'll find actually we get these sorts of problems. Let's dive in on this one.
All right, so it's a continuous process, and you adapt.
Yep.
Yeah, by the way, I love asking these questions because, well, for two reasons. First of all, it's sort of a payback. Like every time if I'm working with a team or with a customer and they ask me a certain question, like how to approach this or that, and most often than not, the answer is depends. So they let's figure it out, and you can see their disappointment. It's like, yeah, they expected the clear recipe. So that I'm doing the same. But the other one is indeed, because then it, most importantly, it's how you describe it. You explain the way you approach it from, let's say, a mindset perspective, and how you think around it, and how you adapt. So this is valuable. And another question would be, starting from an example. So these are testing, you use various techniques for your project. So testing how things are implemented in your project. But for instance, we had in the first day a conversation with Kevin Henney, and he showed at some point a really nice example. There were two bookstores that only they had a certain book. But each bookstore had an algorithm. One that had they had it in stock, and they had a lot of stock, and the algorithm was, okay, look at the other prices on the internet, and from the lowest one, drop another 10%, and that's our price. And then the other bookstore was, they didn't have stock. So they said, go on the internet, check out another bookstore, then increase the price by 10%. Something more. So what happened before you know it is that each day these bookstores were updating their prices for that book, and it ended up with millions. Or somebody knows. Not sure if it's if you know the specific example or not, but how do you check for things like that? Is there any way to prevent this, or it's just yeah, if you find out, you deal with it?
Yeah, that is an interesting one, and I must admit the dynamic pricing. It causes me all sorts of trouble, because the more times you look at something, the more the price changes, which means it's not so easy to automate. It's not so easy to put into a technique. I would probably push that more towards a manual, experience-driven, exploratory type test approach, because but then, given a bit more time, I'm sure I could think of a technique that I could work that one with. But at the moment, can't think of anything straight away.
I think the essence of this is that, yeah, we do a lot of testing, or hopefully for to test our system, but a lot of times in isolation. But once it's out in the world, it's impacted by a lot of factors.
Yeah, and that's another one of those that experience as a tester. You add all of your test experience together to come out with what you're doing as a tester. So the minute you have experienced dynamic pricing, because you looked at a website on your phone, and then you looked at the same website on your desktop, and suddenly, I was booking a hotel room a good while back before COVID. And the fact I checked a price on my phone and then went to my laptop in order to actually book it rather than try and do it, the price changed. And then it was like, well, can I go back to my phone and book it on the phone, because I've got it there as a cookie and I can do something? And of course, you go back there and no, the price has changed again. As a tester, you add that to your experience. So if you are starting to work with a system where dynamic pricing is going to be in play, the little light bulb will go off in your head and say, I need to add that to my list of tests to look at, because I've experienced this. I need to think about how I'm going to test it.
Indeed. And I have another one. It's based on your experience, I mean, we all know the testing pyramid and how it should, how things should look like, what sort of, how many unit testing we need to have, integration and so on in manual. But when you look in real life with the projects you've been involved to over the year, how does that image look? Is it like that? Is it like an ice cream cone? What's your take on it?
I said during the talk that, you know, basically I'm a visual thinker, so I'm always trying to find a visual that will fit with the project. But every project has a different fingerprint. So it really, that is a it depends answer, because yeah, every project has a different fingerprint. If you start with the risks that the project may face, that what the application may face, then you can see where to apportion your test effort. If it's got a very complex code base, then invest more time in the code base, invest more time in static testing techniques to get it right first time. If, on the other hand, it's more of a user interface type system where the applications are, well, back to the dynamic applications, then you're going to need to invest more time at the higher levels or the later stages, depending on your project methodology. But every project is a different shape. I don't know if you have the Mr. Men books at all in Romania, but you have in that pretty much project images. You have Mr. Squiggle, who's all wavy and all over the place. You've got, I can't remember this, there's a square one where we're basically saying all the testing should be the same throughout the project. As long as when you slice the project somewhere there is testing happening, then great. As to where to apportion that effort, well, that's a bit more complex.
All right. Yeah, I'll definitely check out this book.
Yeah, the Mr. Men series. Yeah, Mr. Men and Mr. Men and Mrs. Anyway, that there's lots of them. They're for children, but it's the images you got for Mr. Squiggle and Mr. Happy and Mr. Tickle, Mr. Grumpy. So
I've got 2 young kids at home, so then it's definitely a good investment anyway. Yep,
I shall get a few books and then add them into my testing library so as people can see what I'm talking about when it comes to projects.
Okay, so well, thank you very much. Yeah, we're not gonna say goodbye because we're gonna meet shortly. Now we're gonna have Isabel's session that I think you briefly brought the essence, like it's the magic of automation or the illusion. And but then we're gonna have the panel and it's gonna give us the time to chat some more.
Brilliant. Thanks very much. I'll go and get a cup of tea ready for the talk.
Perfect.